All right, last graph shape we want to figure out. X to the power of 2/3, which is weird. And then what? The cube root of x squared? And also uh, the cube root of x squared? That's weird. There are equal signs there, which seems to imply that all of these things do the same. Yeah, that's true. Numerator is your power, denominator is your root. Doesn't matter which order you do it in, just like multiplication and division. So, what does it look like? Well, when I think of this, I think of two different steps. I look at that first. I say, okay, let's talk about the cube root of x. Well, from before, I already know that the cube root of x crosses 0, 0. I know it also goes through 1, 1. And I know it also goes through 8, 2. And then all of that flipped stuff as well. So again, acknowledge that my scale is changed. X direction by 2, Y direction by 1. But there is my cube root graph. Red is cube root right there. Burp. Gross. I'm disgusting. But think about what we're doing next. Now we're going to take that cube root graph and we're literally going to square it, which means all of those y values from the cube root we're going to square, and that's going to give us our 2/3 graph. So 0 squared, well, that's still 0. Still 0. 1 squared, that's still 1. Negative 1 squared, that's positive 1. So notice what's happening. That bottom branch is being flipped up. 8, 2. Well, 2 squared is 4, and so I must have a point up there. Negative 2 squared, also 4. So I have that. Everything's flipping up, and I have this graph that goes whoop-de-woo. And I call it the bird graph because it looks like those birds you used to draw or still draw. But that's that. It is two graphs combined. It's a 1/3 graph that you have squared. You can think of it as a squared graph that you cube root, but that doesn't work for my mind. But I can do this. So let's erase that red real quick, just so you can look at this by itself. There you have it. That is our 2/3 graph. Domain and range. Hopefully you feel good with this by now. Domain is going to be all real numbers because I can square any real number and I can cube root any real number. So domain is x in r such that nothing, it's just x and r because I can be anything. So negative infinity to infinity is the set of numbers that x is in. And then what about my range? Well, again, all positive numbers, just like the square, just like the cube. So I'm going to say y is an element of all real numbers, and I'm going to list it in interval notation in the same way. Y is an element of the interval negative infinity to positive infinity. There you have it. A strange new function to us, but piece it together one step at a time, and you've got it.